Okay, electric current and Ohm's law. Let's say that we have some conductor, and let's say that we have applied some voltage difference at the end of that conductor. Then there will be electric field inside that conductor, and since we have free electrons inside the conductors, free electrons will start moving, and there will be a current. So we have two directions of current. We have actually like a physical real direction of current, and the real physical direction of current is from minus to plus, and that's the real direction of electrons. But the technical direction of current is from positive to negative, from plus to minus. So that's the just convention, and it is what it is. Let's say that we have a copper, and let's say that we have a copper on room temperature, like 27 Celsius degree, and on that temperature, free electrons have a speed, and this speed is quite remarkable, and it is 10 to the 6 meters per seconds. So yes, it is like 1,000,000 meters per second. So yeah, it's quite amazing speed. Also, on the room temperature, we have like the time between collision of the time between collision of free electrons. It's about 10 3 to the 10 to minus 14 seconds. Also, the number of free electrons inside the copper, it's about 10 to the 29. It's in meter cube, and each electron has a mass. It's about 10 to the 13 kilograms, and of course each electron has a charge. It's about 1.6 times 10 to the minus 19 coulombs. And now let's try when we apply some voltage difference. When we apply some voltage difference at the end of that conductor, that wire, there will be electric field, and electrons will start moving. Now let's try to calculate that speed of electrons. Let's say that we have a wire which is like 10 meters long, and let's say we apply like 10 volts at the end of that wire, and when we apply voltage difference, there will be electric field, and each electron will experience a force. So the force of each electron is that amount of charge, that has electron times electric field. And from this formula we can write that acceleration actually is mass divided by force divided by mass of the electrons, and this will need to calculate the speed. So the speed of electrons, let's call this drift velocity. We can write something like this. We have acceleration times tau, which is time between collision of free electrons. Electrons, it will, electron will start moving, and it will move, and then it will collide with another electron, and then it will stop. So this is why we are calculating with the average time between of collision. So the time and the acceleration, we have the speed, right? This is basic physics. So we can express this acceleration as force divided by mass times time between collision, and then we can express this and write like this. So force we can replace with electrons times force, electric field divided by mass times tau. So basically I just replace it here, force with this. And now if we take some real parameters and replace in this formula, let's do that. So let's say that we have, okay, each electron has times 10 minus 10, and then electric field, okay, it's a 1. So electric field here, actually, if we have a wire which is 10 meters long and we apply 10 volts at the end, actually electric field is 1 volt per 1 meter. So we have 1 here, and let's replace the tau. Tau is 3 times 10 to the minus 14, and at the bottom we have the mass, and the mass is 10 to the 30 kilograms. So if this calculation is correct, and I think it is, it's about 5 times 10 to the minus 3 meters per second, and this is about half a centimeter per meter, so half centimeter per second, sorry. And this is very slow. It's, I don't know, I think the snail it's faster, or turtle or something like that. So it's quite slow. It's like for 10 meters. So in this example, for a wire of 10 meters, it will take one electron to travel from one end to another one. It's like 30 minutes. So it's quite slow. Now let's try to derive Ohm's law. Let's say, okay, that we have a wire with some cross section A and some distance L. It doesn't matter, it can be like 10 meters, it doesn't matter. And when we apply some voltage difference at the end, we have electric field, and electrons will start moving with this speed. And now let's try to calculate the current which will flow through this conductor. So we know that current is, by definition, it's number of coulombs per second. So now let's try to calculate what will be the number of coulombs that will pass through this cross section A. So we have like speed of electrons, which is Vd, which we already calculated above, and now the amount of electrons that will pass through this cross section is A times the number of this n is a number of electrons in 1 cubic meter. So this is the number of electrons which will pass in 1 second through this cross section A. So through this cross section A. And now if we multiply this by electric charge of each column, it's A, we have a current. And now we can replace we can replace this with D. Now let's write like so. Let's replace this with D with formula above here. So we have A square times m times tau divided by mass times cross section times A. And this here it's actually this is sigma or conductivity, and we can replace here, we can write sigma times A, but electric field here we can replace with this, and we can write V times L. And now we can rewrite this formula like this. We can write it's L times tau times A times E. And actually this is the Ohm's law. So this here is resistance, and this is the final form of Ohm's law.